Hi everyone, good morning, good afternoon, and good evening. I hope you are having a great time at TestMu conference. Welcome to this session on auto-generating accessibility tests straight from your GraphQL schema. I'm Himanshu, Director Demand Generation at TestMu AI, and I'm tuning in from TestMu AI's Noida office, India. I see folks joining in from different parts of the world. I welcome all of you. I hope you'll have a great time here. A quick request to all of you before we start, please share all the learnings on LinkedIn and X. You can tag us using the hashtag TestMuConf so that the rest of the community can follow along. Now, moving on to today's topic, the problem with accessibility checks usually arrive late, and more often than not, they're flaky too. So, the question which we have on the table is, what if accessibility was something you declared upfront, not something you audited later? And to help us answer that, I have Vanessa Johnson with me, Android engineer at the New York Times, working at the intersection of mobile engineering, accessibility, and developer tooling. She builds open source tooling that makes accessibility a first class part of the workflow instead of an afterthought. And the interesting part for this session is she'll annotate a schema, run the generator, and execute the resulting specs on stage live. So please join me in welcoming Vanessa. Over to you.
Hello, good morning from New York City. Like was said, my name is Vanessa Johnson, and today I want to show a practical way to stop guessing accessibility in tests. The core idea is instead of handwriting brittle playwright checks after the UI is built, we can declare semantics once in GraphQL, generate some tests from that marked up schema, and then let the browser prove whether the semantics were actually kept. So we'll need to embed our accessibility information or our metadata into our API, and we're going to be doing that using directives. And then we're going to be diving into auto-generating playwright tests from that schema. So before we dive in, a little bit about me is that I'm an Android engineer at the New York Times. I've been there 2 years now, and I work on the Games app. So if you've ever heard of Wordle, Connections, maybe even Pips, that's the team that I work on. And this talk grew from asking, what if GraphQL knew accessibility? This version shows how it can provide accessibility information and how to test that information we get back from the API. So making accessibility a first class citizen API design that can work across your different platforms. So let's start off about why accessibility matters. About 16% of the population have some sort of disability, which equates to about 1.3 billion people. These numbers are a reminder that inaccessible experiences affect real people, real tasks, and real products. And about 71% of people leave inaccessible sites immediately, and that will result in loss of customers due to poor UX or UI, or hard to go through flow. And then about 4% of the web is actually fully accessible. So if teams don't hone in on the steps that they can take to make their features or products more accessible, or if their testing strategy doesn't catch those semantic issues early, we're effectively choosing to let those issues reach users and miss out on a potential target user group. So as you can see, this is a large demographic. So depending on the steps that you're taking to make your apps or products more accessible, you're missing out on that potential revenue or potential user group that can be using your products. So some common web content accessibility guideline failure types are low color contrast, missing alternate text for images, missing form input labels, empty links, and empty buttons. So we're going to be honing in on the missing information that needs to be fed into accessibility tools. So if you work on like Android, that would be TalkBack. iOS would be VoiceOver, especially on Mac. And then for web, there are different tools that you can use. But these failure types are common because teams usually check accessibility after layout and functionality are already done. So that can be like missing names, weak structure, and any confusing focus behavior. And then those are not really rare edge cases. They are predictable outcomes of workflows where semantics are added late or when communication between teams could have been better. So those examples show that there is a gap in our APIs, or at least room where we can shift that accessibility talk left in the features workflow. So so many times the accessibility is added late. It's an afterthought, typically addressed during UI implementation long after the API contracts are finalized, or maybe the last push or last milestone to get a feature out. And that can lead to inconsistent implementation. So each team implements accessibility differently, leading to inconsistent experiences across platforms. So you can kind of think of it a way as where you have an architect that builds a physical building. There are many aspects that go into the blueprints from upfront, like walls and ramps. But many times there are software engineers that are putting in like a new feature, like the infrastructure. Accessibility is usually treated like a coat of paint slapped on at the end, kind of like, just make it look pretty for when people come in to see if they want to buy the house or not. So it's just a way for you to take that may be considered a small detail, but it is impactful feature or addition for people that need that extra piece of information. So with those gaps comes with pain points that can arise where there's no single source truth for accessibility. And so that's labels, roles, descriptions. They're scattered across client implementations, creating inconsistency. There's client-side string stitching is brittle. So usually you would assemble the text from multiple fields depending on the information you get back from API. And then that will break depending on the data, if it changes or if there's localization that needs to be added. And then semantics can drift across platforms. So if you are having your product or your software on multiple platforms, sometimes it can diverge, and we don't want to have inconsistent experience depending on the platform that someone's on. So that's just how you can get noisy tests and then inconsistent user experiences along the way. So with those in mind, let's look at how constructing the accessibility information on the client side can look like. So the client will fetch some data. So for this example, let's think about a movie list. So I make an API call, I get my list of movies, and I store a movie in this movie object. And the movie object will say that will have a title, a rating, and release year. So I take those pieces of data, put them together, and make some sentence or some string that can be applied to a component. So right now I'm applying it to a content description. So that's just the accessibility information that I'm applying to a component that will be fed into an accessibility or screen reader that will let the person know what they're on when they have that item in focus. So this can be brittle and duplicated. So you'd have to make the same construction on all platforms. But depending on if you want to add more information on the UI to say, like, I'm going to provide more information or remove information, then you would have to go in, edit the string so it's consistent with what the user would be seeing. Phrasing varies per developer. So this can probably be mitigated more if you have increased communication between your developers or have like a spreadsheet or a doc that says this is what the string, how it should be constructed. But there's still some times where things can happen where it doesn't exactly match. And then, so the key insight is that this pattern can become unmaintainable as your UI changes or if your data changes. So you can think of it as you're 3 different chefs and they have all these ingredients and you're hoping that they cook the same meal, but they don't have a recipe. So it could come out the same, maybe not. Seeing that, the core claim is that the server should ship semantics too, but I'm not really saying that the server replaces the accessibility work in the UI. I'm saying that the server can provide a contract for meaning and the UI can implement that and verify that meaning more consistently. So keeping with our movie example, we have a type of movie with our 3 pieces of data, and we can use that to derive our area attributes for web, our compose semantics for Android, for iOS would be our accessibility label, and then we can feed that into some CI validation to make sure that we are checking along the way to make sure that nothing regressions or diverges. So schema as a contract. The schema defines semantic requirements, not just your data shape. Your client agnostic, so web and mobile can map their native semantics. And then you can use CI enforcement to catch regressions early. So before I show directives, which is how we're going to be implementing this, I want to define the things that I kept in mind. So this has to be additive because no team is going to accept a huge breaking schema rewrite just for accessibility. It has to be optional. So for old clients, it should still work. It has to describe meaning rather than presentation because the styling of the page is not what the assistive tech consumes. And then that can also change depending on if you have a redesign. And then it has to be stable over time because unstable names can create unstable or flaky tests. So I have a sandbox on GitHub that I'll show at the end, where it kind of has a demo or that I'm showing today, but also you can run it yourself. But we're going to be looking at the directives catalog that is supplied in that repo. So starting off, we have accessibility label. So that defines the accessibility label for a field used as the primary identifier for screen readers. Accessibility role, so it defines the role. So whether something is a group, a button, a link, or an image, or something else. Accessibility template, so that defines a template for descriptive text. So we're going to be talking a little bit more about this, but this is a way where we can compile our data together to make it sound more human readable to the user. And then accessibility token, where we can map a field to a token to use in the templates. That's going to be the sentence that we make, but more on that in the next few slides. So going a little more into detail about the directives. So this accessibility label, it tells clients that this is the primary label you should read. So human readable label, and then why it matters. So it provides the main identifier that the screen readers announce first. So when users encounter that object, and then usage patterns so apply to the object type or individual fields, depending on your use case or how you want to write it. Because obviously these are custom directives, so you can change it depending on what you need. And then it points to the field that best represents the object. Next, we have the accessibility token, where this is more for you to provide more flexibility in adding additional information to each attribute. So the data type and the field name this token represents, like say if you're working with money, you can include that this is a price. If you're talking about ratings, like say for our movie example, we would have a rating piece of information added. Priority, so order of importance for screen readers. So this is going to be more important for the template that we make, where we can decide the order of how the information should be presented to the user. Unit prefix or suffix, so formatting the numbers with currency symbols, percentages, or unit labels. And then sometimes, depending on if you've done like manual testing, instead of the screen reader saying 299, it might say 299. So just making sure that those things are pronounced correctly. So for the accessibility template, it ties it all together into actual sentences that screen readers can announce. So we use the field name syntax to reference schema fields in the template. Natural language, so it creates a human readable sentence that screen readers can speak naturally. So it flows better to the person that's on the screen. And then dynamic assembly, so runtime submission, ensures summaries stay current with changing data. So when you are querying for something, that those components will show up in your sentence, but if you're not querying for it, then it won't be within the template. Now we can combine those three. The schema now carries its own accessibility story right alongside the data, with adding the accessibility attribute to your schema. So here this is just a generic template example where we have your type. You can apply the template on the type itself, and then you can apply the label and tokens on the attributes. So like I said before, the accessibility token can be applied to a single attribute. So for price, we're saying that it's a price, and we're going to have it have a prefix of $. And then we have the accessibility object at the bottom. And then on the right, we show what the accessibility type consists of. So it would have the label, the tokens, and the templates. So we're going to be really looking at more of the templates because that makes it more human-like when we're speaking out to the person who's like, hey, this is what this shows. Now looking at keeping with our movie example, we have our type movie, and we're having all of the directives annotating on this type. So we have a role, and we can say that it's a group of information for the movie. So we'll be spoken out together. We have a template where we're going to be talking about the title, rating, and the release year. So if someone decides, okay, I'm interested in this movie, and it gives them this bare bone information. And then, so this is like the first half of the type. And this is the second half, since they all couldn't fit on one slide. But the detail I want you to notice is that each piece has a job. The title is like the identity, and the rating and the year are semantic details. So the template determines how they are spoken together, and that is much more reusable than scattering accessibility strings across your UI code. So to sum it up, Accessibility label defines this primary identity for screen readers. The role is the structural meaning, and the template plus the tokens is your descriptive output. So to make this all possible, we have to wire up our schema in a smarter way by starting off with your schema, and you add the accessibility directives. We build the schema out. We have a plugin that we run in our resolver, and then we get the accessibility object field in response. So we can query for our data, including the accessibility attribute, and get back the specific pieces we asked for without any extra information. So on the left, we have our query, and then on the right is an example of a response. So it's a small data set that I use for this example, but we have a title of inception, the release year, and the rating, and you can see in the summary how it's constructed based on the annotations that I used before. So in other words, I can receive the structured accessibility information from the same schema that already powers the app. And that is important because now accessibility intent is no longer hidden within your comments or scattered throughout your code base. Okay, so here I'm showing just the querying and then the results on the side. So the same backend contract that gives me all the information also gives me the semantic interpretation of those fields. So it's just a GIF of the querying and then the data set with the summaries. Here, I'm just showing the template summary only includes what you query for. So here, since I'm only querying for your title and your rating, that's the only thing that show up in the summary. By the time we've reached Playwright, where GraphQL is no longer the thing under the test directly. The browser is what we want to verify because that's what the user experience. But the schema still matters because it's the source of truth that tells us what the browser should expose. So the generator so we have schema directives. So we defined our explicit semantic meaning and intent. The generator turns the schema into test expectations. So we have like the JSON that comes out of it. The browser computes the accessibility tree from the DOM, and the Playwright verifies computed semantics match the spec. So the browser interprets the markup into roles, names, descriptions, and any relationships like the list items in for the movies, and then Playwright checking that computed semantic output. Okay, so we still need semantics at the GraphQL layer in this approach because that is where we declare our intent once, generate tests from it, and create this rules the UI can be held against. So here we have our role as a list item, our name is inception, and the description is what we're going to be checking. So we're making sure that this accessibility string that we get, it matches what we constructed before. So the reason this matters is that accessibility bugs usually show up at the browser or accessibility tech layer, not at the schema layer. So my generator has to translate schema intent into browser assertions. So in the demo in a few slides, we're going to show some commands that we can run using the repo that I'm going to supply at the end, just to show what the test catches and maybe how it's a little bit flaky, what can be improved. So the key takeaway is that tests assert the semantic meaning computed by the browser and not the raw implementation details. Okay, so this is the generated JSON spec. So it's a contract that kind of sits between the schema and the test framework. In the repo, the generator reads the GraphQL directives, combines them with the sample data. So it's like 3 movies, some small data set, and emits a plain expectation object shown here. What the page I'm testing, what the role I expect, and what the user-facing semantic output I expect. So that's the description. So the role defines the structural meaning, the name, the primary accessibility label for screen readers, and the description is assembled with the template. Okay, so the generated Playwright test opens the demo page at the specific path and compares the browser output against the generated expectations that we saw in the last slide. So in a specific demo, the movie will map to a native list item. And then after those contract checks run, we're gonna run like the generic general Act core on the same page for the broader like WCAG audit. So the file is intentionally simple. Open the page, apply the contract, verify the browser, and then run the generic accessibility audit. Okay, so like I said in the last slide, this is part of the generic accessibility checks to focus on to just make sure we catch those easy catches and to focus on more general accessibility standards instead of every possible experimental or best practice rule. But this is just a way for you to catch the easy ones to say that okay, these need to be fixed, and then we can go into the more specific use cases of hey, this component should say this. This is how it should be communicated to the user. This is the experience that I want to portray. Okay, so these tests are less flaky because they're anchored to the semantics that should be stable over time. So if you obviously change something in your semantics, then your tests and your descriptions need to change. So in the sense of the CSS selector might break because someone wrapped a div or renamed a class. So we shouldn't be making it tied to how something looks. It should be the value or the semantic description of the component itself. So obviously, like less flaky doesn't mean it's impossible to break. If I choose unstable names or let roles change or change something in one place and not update somewhere else, then obviously that's going to create noisy tests. But the point is that the architecture moves toward intentional semantics. So of course, live demos don't always go to plan. I've tried live demos here at other conferences, and sometimes they don't work because of network connection. Sometimes the videos don't play. So let's hope the videos play this time. But here I'm running to generate the JSON file that we're going to be testing against. So it takes the sample data that has the three movie objects, and then it creates the file that we're going to, and the Playwright test file. So just play that again. It's just a command that you can also run with the repo. After running that, we can go and run the test itself just to make sure that to see if we can catch anything. It's running that. Okay, so obviously this one intentionally fails, but we can see that the expected sentence does not match the received. So this can be an example of maybe it's flaky because are we making a big deal about a period? But depending on what you need and how precise you need to be, then this will catch those little discrepancies of this is maybe not ordered correctly. This is not ordered the same as somewhere else or where it should be. So this is an example of how this can be used to catch simple things like this. All right, so I went in and I fixed what the string template should be. And now I'm rerunning the test and it should give me a passing test. So even though that test failed, it gave me a way to say, okay, well, I need to go in and fix something's not correct, something doesn't align with where it should be. And then you can also, so that would be something that you can run on each platform. So this is
movies.
So before I run this, the movie row is exposed as one coherent sentence. So depending on what you want, this is say this is what I wanted. Like I wanted this to be all spoken out to the user, compiled up into kind of like a wrapper of some sort where I can get all information in one swoop. The name of the movie, what was rated, when it was released, and I can decide if I want to click on it to learn more, and then to see if I want to watch that movie. So
Web content.
This is just showing this running a screen reader on this page.
And You Are the Dark Knight, rated 9.1 out of 10, released in 2008. You are currently on a selectable text. Interstellar, rated 8.6 out of 10, released in 2014.
Okay, so this is just to show that this is what I wanted it to portray of having it being selectable or having the whole row be selected together and announced together. But depending on the screen reader that you use, there's default information that you're going to be hearing. Like say, like it tells you this is a selectable text or you're in a group, things like that. So depending on which one you're using, it might vary a little bit. All right, so this is the unwanted
movies,
state.
webcom, movie list, group. You are currently in a group. Inception, group. You are currently in a group. Inception, rated 8.8 out of 10, released in 2010. You are currently on a selectable text. End of Inception, group. The Dark Knight, group.
So I guess it really depends on what you want. But for me, I feel like this was more kind of fragmented and I wanted to be grouped together in a nicer way. So this is just an example of what I wouldn't want or what I don't want. So in this walkthrough, the role of each row changed, which affects how the screen reader goes through each element. So here the semantics drift from the intended experience. And that's exactly why I want the test to fail. So this would be an example of a failure test. The value is not just that it fails, but it fails with a meaningful signal saying that either that the rendered semantics changed or the contract changed or something along those lines, and we need to realign to make sure that everything is where we want it to be. All right, now, how can this approach be incorporated into your workflow if this is something you want to explore? I wouldn't start with the whole app, and I don't think anyone would. So you'd want to start small, maybe begin with 5 to 10, or maybe even one screen to identify a key screen that that maybe a lot of users use, prioritize user flows, focus on repeated elements. So I think this works pretty well with like lists, something that is in a repeatable kind of arrangement. So say like we have, or a groupable arrangement. So the row has a group of different components together, and that can be grouped together to be spoken out as one. So depending on your use case, it may not work one-to-one. But since the beauty of using custom directives, you can change it to fit your use case, but still have the same principles of feeding that information and feeding that information from your API into a way, or feeding it where your clients can receive that and then apply it to the components that it needs to be on. So prioritizing patterns, like I said, focus on repeated rows, list items first, card components, repeated patterns, establish a glossary. So create some shared naming convention, define token names, kind of had like a resource doc or a page where people can refer to say like, hey, this is how things should be constructed. This is what it should sound like. And then obviously you have like your automated testing tools that you can use that everyone can use, like accessibility scanner for Android, but you'd also want to step through manually to make sure that the user experience is what you expect it to be. And then obviously with all that, you need team alignment, and then assign ownership. So who's making the PR list, who's creating the semantic ownership, and then the review process. So this is also a collaborative effort between UI and backend, and then anything like that. So final thoughts, since I have like 1 minute left, is accessibility should not be something we reconstruct from scratch in every client. We can declare semantics once, generate useful test files from the contract, and let CI catch drift before users do. The expectation here is not just more tests, but better alignment between teams and more trustworthy feedback. But if you need a sentence to sum it all up, embedding accessibility messaging into the GraphQL schema is a single source of truth of messaging should be, and the testing that the Playwright tests use to make sure that the messaging presented on the browser is in the way that we wanted to be constructed and to be expected. But like I said, who owns the directive is more going to be a cross-functional team effort to make sure we all align, product and engineering, and then we have to think about what if things are missing. Thank you. If you want to continue the talk, talking about this topic, you can find me on LinkedIn, my portfolio, and anything like that. And then this is the GitHub link if you need that to test app. Thank you.
This was so insightful, Vanessa. Thank you so much for such a great session. I'm sure everyone enjoyed it as much as I did. Uh, and I think people took a lot of takeaways. I encourage everyone to post those learnings on LinkedIn and Twitter. I see a lot of questions lined up, but we are over time. What we can do is we can answer them in the community channel. But we have many more sessions lined up. You can check the agenda. Thank you so much, everyone, for joining in. Keep learning and happy testing. Thank you.
Thank you.